In this video, we're going to start by introducing random walks. These are one of the most popular activities we do in Math 9, and I believe every quarter of Math 9 does some form of random walks. And it's because, one, these are a really good example of how we can use for and while loops to kind of model concrete problems. But also it's one of those things where in maybe your stochastic modeling classes, you spend a lot of time learning about how to deal with random walks kind of just with a pencil and paper. But here's an example of how we can understand them using MATLAB, and maybe it makes a little bit more sense this way, or maybe it just clicks in a different way. So I'm excited for this kind of section of the course, so let's get started. In this first video on random walks, I'm going to show you the for loop method, but first let me explain, well, what is a random walk? You can imagine a number line, so let's say we have 0 kind of at the center, and imagine you are just kind of, with random chance, either you take a step to the left and you end at -1, or you take a step to the right and then you end at 1. And then you could take another step. So you could either go one space to the left or one space to the right. So notice in this setup, we don't have the option to stay put. We'll see a little bit later about how if you want to stay put, we can kind of introduce that. But for now, let's just assume you have to move left or you have to move right. So the for loop method, the way this is going to work, so remember, for loops run for a fixed amount of time. So when we kind of do a random walk with a for loop, what that means is we're going to assume that we're taking n steps. So n random steps to the left or to the right. So let's start by creating a function. So I'm going to say new function, and maybe because I did talk about the for loops, what do we do with the while loops? The while loop random walk is going to run until we're a certain distance away from our starting point. So that's what we're going to use the while loop for. But for now, we're going to do the for loop. So I'm going to call this walk1. As input, I'm going to have an integer n, and this represents how many steps I want to take. And as output, I'm going to give a vector v that represents every step along the way. So in a comment, let's say something like, so with a for loop, start at 0 and add plus or minus 1 randomly for a total of n times. All right. So remember in a previous video, I talked about how can we pick a number plus or minus 1 at random. And remember kind of the least or the less flexible way, but kind of single line way of doing it is we could say for step, let's call it s, I take -1 and I raise it to the power rand I2. So remember, rand I2 gives me either 1 or 2. And then, so -1 to the 1 will be -1. -1 to the 2 will be 1. So this is how I can get -1 or 1 at random. So that's how we're going to model it. So let me kind of delete this for now, just a refresher. But let's say, okay, we're going to initialize our vector to start at 0. So normally in this class, we initialize an empty vector. But for now, I'm saying let's start at 0. And now we have our for loop. So for I equal to 1 to n, I'm going to say v is equal, maybe I should call this, how do I want to do this? Yes, okay, let's do it like this. So v is going to be v comma. Now, so remember what this notation means is include v. Now we're just going to add on a new element. And what we want to do is we want to look at the last element of v and add plus or minus 1 at random. So I'm going to say v of end plus, and now we're going to do the code for how do we get our random plus or minus 1. So rand I, or sorry, let's do -1 to the rand I of 2. All right, this looks good. Let's save it. Oops, let me end the for loop. Let's save it. So this is going to be walk1.m. And now let's try running it. So let's do walk1 of 5. Now remember, 5 means I take 5 steps. So here we can say, okay, start at 0. I take 1 step to the right, that's 1. Then another step to the right, that's 2. But going from 2 to 1 means I take a step to the left. Then I go back to 2, so to the right, but then again to the left. Let's try it again. So here I can see, okay, I go to the left, to the left, to the right, to the right, to the right. And I could do something like walk 1 of 100. And we can see, okay, where does this end? You can see I end at -10. But kind of scrolling through, I can see where else did I go. So it looks like, okay, we went up to 4, there's 5, 6. So looks like we got up until around 6 and then end up at -10. So some basic questions that we can ask about random walks is kind of what we just answered. Where do we end up? So after I walk 1 of 100, you can see I end here at -10. And you can also ask, well, what's the farthest you get from the origin? So -10 in absolute value is 10, so that's 10 units away from the origin. And I think that was the largest number in absolute value that I saw. In general, the kind of end element and the farthest element don't have to be the same. So let's run it again just to see. So you can see here, I end up at 0. But okay, I got to -5, so it's a distance of 5. There's 6, 6 again, 7, and so on. So good example of how where we end doesn't necessarily have to be the largest element, or like the farthest from the origin, so the largest in absolute value. Maybe one thing I want to show you that's a common mistake. So remember I said our random walks are going to force our walker to either go to the left or to the right, so there's no option to stay put. But a mistake that's pretty common is I could say, okay, plus, let's do rand I -1 to 1. And do you remember, what does this do? It picks random integers between -1 and 1. So that means 0 is also an option, so meaning we add 0, we don't do anything. So this is how you could code a random walk if you wanted your person just to stay put, but for us, that's not what we want. So we can see here, oops, let's see. So 0, 1, 2, 3 here, you can see we have 3 and the person stays on 3, for instance. So this is a mistake. We really do want it to be just plus or minus 1. So I'm going to fix this again to be -1 to the rand I of 2. All right, I think this is a good place to stop this video. In the next one, I'm going to show you random walks with while loops, and we're going to talk about the situations where you'd like to do that instead. Thank you for watching, and I'll see you there.